All right, my friends, let's take a look here. So convert each polar equation into rectangular form. For the first part B, which should have been called part A, just for the record, theta equaling 2 pi over 3. I hope it makes sense you are expecting a line graph, because if your angle is fixed at being 2 pi over 3, but your R value is totally unrestricted, then you would get, a line graph. So as far as converting, you'd be reaching for the identity tangent of theta is y over x, and then your theta value is 2 pi over 3, like so. And then from there, you'd need to evaluate the tangent of 2 pi over 3. So that's just the sine, or the y-coordinate, which would be square root 3 over 2, divided by the cosine, or the x-coordinate, which would be negative 1/2. And then from there, you just need to simplify by just kind of flip and multiply type stuff. And then you could write your final answer as either y over x is equal to negative square root 3, or you can multiply both sides by x, like so. Anyway, so there you go. Scoring for this one, let's see, let's give you 2 points for having this work as part of your support work at all. And then 1 point for evaluating tangent of 2 pi over 3, either in this compound fraction form or getting it to simplify to negative square root 3. If you didn't show the work, you just got to here, then that's kind of the same thing. So I'll put the point here, but if you skip to that, then that's fine too. And then the last point would be for getting this answer, or I guess this one. They're both technically in polar form, or sorry, in rectangular form. So either of these would count. There you go, and that's your 3 points for that one. For part B here, R equaling negative 6 sine theta. Oops. The fastest way to go about this one would probably be to just replace sine theta with y over r. And then you could multiply by r. And then r squared could be swapped out for x squared plus y squared. There you go. So, and then you'd be done. There are different ways you could write that, but as far as the directions went, then you're pretty much done. So, let's see, let's give you 1 point for swapping y over r in for sine theta, 1 point for replacing r squared with x squared plus y squared, and then 2 points for getting the final answer here, x squared plus y squared equals negative 6y. Okay, now for part C, sooner or later you could replace r squared with x squared plus y squared. You wouldn't have to do it right up front, but at some point you probably did that. You'd need to replace cosine of 2 theta with something in terms of single theta. So using the double angle formula for cosine, you could replace it with cosine squared theta minus sine squared theta. There are a couple different versions. There's also 2 cosine squared theta minus 1, or 1 minus 2 sine squared theta. We should get to the same place no matter which one you picked, but one of those 3 should go in there. And then from there, you could replace cosine with x over r, but then it's getting squared, so you get x squared over r squared. And then let's combine these fractions together over here on the right. And then you can multiply both sides by r squared, or replace r squared with x squared plus y squared. I think I'll go ahead, since I had already done that on the left side, I think I'll go ahead and show that version of the answer. And this is one version of the answer. Another version would be where you clear the fraction on the right side by multiplying both sides by x squared plus y squared, in which case you'd have the quantity x squared plus y squared squared equaling x squared minus y squared. Something to that effect. So let's see, scoring for this one, you get 2 points for using one of the double angle identities for cosine correctly. So either replacing cosine 2 theta with cosine squared minus sine squared, or replacing it with 2 cosine squared minus 1, or replacing it with 1 minus 2 sine squared theta. One of those three. You get 1 point for replacing r squared with x squared plus y squared anywhere in your work. Like for me, it would show up here for the first time, like that. Let's see. And then how did I square this last time? Oh, okay. And then 1 point for replacing cosine theta with x over r and then squaring it. Like that. 1 point for doing the same thing with sine, replacing it with y over r and then squaring it. There we go. And then 1 point for getting one of these final answers for that one. 6 points altogether. All right, let's look at problem 4. There was some confusion as to what I meant by problem 3, part B. Some of you thought I meant the first part B, and some of you thought I meant the second part B. Well, I definitely meant the second part B, but because it's kind of my fault that there was some confusion, I'll give you credit either way. So let me show you what I meant first, and then I'll show you what some of you thought I meant. Anyway, so for part B here, you could graph this by looking at the polar form, and knowing that that's a circle with diameter 6, and then just t-tabling it out. So putting like 0 in for theta, you'd get 0 out. Putting like pi over 2 in for theta, and you get negative 6 out, so you're facing pi over 2, and you go back 6. And then honestly, like with just that much work on a t-table, you could figure the rest out, because if you knew it was a circle of diameter 6, you could figure out the center was here, because that would have been a diameter. And then the radius would be 3, so from your center you go 1, 2, 3, 1, 2, 3. So that is one way to have graphed that circle. Another way would have been to complete the square here. So in which case you could have had x squared plus y squared and then add the 6y over. And then you could add 9 to both sides for those y terms there. And then you'd have x squared plus the quantity y plus 3 squared equals 9. And depending on your experience with circle equations, you could tell that it would have been this circle by looking at this. Or if you don't have a lot of experience with circle equations, then you could just treat it like an ellipse, because it technically is an ellipse. And then you get the same graph. So hopefully that makes sense. You have quite a few different ways to get there. So here are the points. I'm going to give you 2 points for, if you knew that this is what I meant by part B, you get 2 points for getting a circle graph. You would get 1 point for having a radius of 3. And then 2 points from the center at the point 0, negative 3. For 5 points altogether. Now, for folks who thought that 3 part B meant this over here, let me show that. Then you could have known that this would have been a line graph since R is unrestricted. And so I'll show it on here. It's a little easier, of course, to graph on a polar plane, but not impossible to graph down here. I'll show you why. So theta is 2 pi over 3. So R is unrestricted. So here's what it would look like if this array, if R was only positive. But R is totally unrestricted, so you could have had this side as well. I hope that makes sense. So should have been a full line graph. Now I asked you to graph it over here though, so your answer to this would have made the most sense. So you'd have tangent of 2 pi over 3 equaling y over x. Sorry, I'm not going to recreate the wheel. You had gotten negative square root 3 for that. And then if you multiply the x over, then you'd have a line graph with a y-intercept of 0 and a slope of square root 3 is about 1.7. So you go down 1.7 over 1, or up 1.7 to the left 1. And then fill it in, you know? Like so. Anyway, so there you go. No, it's worth 5 points. I noticed some of you just had array, because I think you thought R had to be positive, but R is totally unrestricted, so you need the whole line. So here's some partial credit. If you just had array, then you could get half the credit because you had half the graph. So, so I'll give you 2.5 points for that half of the graph and 2.5 points for that half of the graph. But it would have to be really clear that you knew your slope had to be, that your slope was 1.7 or negative 1.7 anyway. So it should be pretty clear based on your points of accuracy. There you go. And that would be your 5 points if you did your work thinking that I meant this as part B.